All right, so starting off, the domain of a radical equation. First of all, what's a radical?
Something inside of
A square root sign is technically a radical sign. It's a type of radical. So radical is this sign right here. Now, if there's a 2 there, we assume it to be a square root. So this is the same thing, right? Typically, we don't write a 2 root. It's known that it's called a square root. But we have other types of radicals. We have cube roots, and we have fourth roots, and so on. So this sign itself, the little check marky thing, is called a radical. And then vocab word, the radicand,
is inside
with an and at the end, basically. Radicand is the stuff that's under the radical. So you could say in the quadratic formula, because that's on this test, the discriminant is the radicand. Does that make sense? Because it's what's under the radical in this quadratic formula. So it says the domain of the radical equation is the values of x that satisfy the equation. So, for example, what is the square root of 4? It's 2, right? We get a nice, pretty answer out of it. What is the radicand for that problem? What's the radicand? It's 4, and 4 is positive, so therefore we get a nice, pretty answer, okay? But what happens when what's underneath the radicand is negative? It's I. We've done a whole bunch of that with the quadratic formula. What's the square root of negative 9? It is a perfect square, so it's 3, but we have to attach an imaginary number to it, I. Now for today, we don't want anything imaginary, so lucky you, no imaginary today. In fact, that's completely opposite of what we want. When solving equations, we want real life answers, okay? So this is going to be a big no-no today, okay? So the first thing we're going to do, we're going to find the domain of the equation, of the radical equation. And it says to find the domain, we're going to take the radicand and set it greater than or equal to 0 because we want to have real answers. If the radicand is greater than or equal to 0, we'll have real answers, okay? So what is the radicand here for example 1? What's under the radical sign? X minus 3. So all you have to do is take the radicand and set it greater than or equal to 0. And that's all you will ever do. It's as hard as it gets pretty much. Okay, so then we solve for x. What do I do to solve for x? Add 3 over, and that's your answer. Not 0. Do what? Correct, because the 1 is a constant. The 1 doesn't really matter in this equation. The problem occurs is if there's a negative under the square root sign, right? So that's what we're focusing on with the domain. It's basically the problem area. Okay. So what this is saying is, in order to get a nice, pretty answer out of this equation, that my x values need to be greater than or equal to 3. So what's a number that's greater than or equal to 3? 4. So what's 4 minus 3? 1. What's the square root of 1? 1. We get a nice answer. But what if I plug in a number that's less or not greater than or equal to 3? What's a number that's not greater than or equal? 2 or 1. Let's plug in 1. What's 1 minus 3? Negative 2. Now we have a big problem on the left side because we have an imaginary number. Okay. So this would be the domain. And you could, if you wanted, you could write it as interval notation. So 3 to infinity with brackets. Either of those is perfectly good. Okay, so now do example 2 on your own. Find the domain of example 2. All right, so we have 2 plus x is greater than or equal to 0. Subtract 2 over, so x has to be greater than or equal to negative 2. You could have also written that as negative 2 to infinity. Any questions on that? Now, there is one more scenario, and we're actually going to solve this problem later. We're going to solve this beauty of a problem. But when there's 2 different radical signs, basically there's 2 different areas we have to be concerned about. Because if we plug numbers into one of them, we might get imaginary numbers. If we plug them into the other one, we might get imaginary numbers. So we have to make sure we pay attention to both. So what we're going to do, we're just going to do it twice. So x plus 8 has to be greater than or equal to 0. But also for this problem to work, x minus 4 also has to be greater than or equal to 0. So basically, we need to make sure that both of them end up having a positive number underneath so we get real solutions. So subtract 8 over. X is greater than or equal to negative 8. Add 4 over, we get x is greater than or equal to 4. Now it says do the same for both, and this is easier to do if you graph them, if we can visualize it real quick. So, greater than or equal to 0, I'll do this one in red. So, or sorry, negative 8. So greater than or equal to, so close circle. Which way is greater than? To the right. So we're talking about all the numbers to the right and equal to negative 8. And I'll do this one in blue. So greater than or equal to 4. So 4 would be further this way. But once again, greater than would be this way. So it says the domain is the overlapping region. So in other words, the red numbers work for this one. The blue numbers work for this one. But what section of the number line ensures that both of them are going to work? Yeah, the overlapping region. So really, your answer is just this part right here. So I would use a bracket because it's a solid point, but it's 4 to infinity. So it should make decent sense. Does that make sense, everyone? And the overlapping region is the part where both of them work. It should kind of visually represent what's happening here. That's as hard as domain can get.
Radical equations, or equations that involve square roots or maybe even higher power roots. But we're going to also try to understand an interesting phenomena that occurs when we do these equations. Let me show you what I'm talking about. Let's have the equation, the square root of x is equal to 2 times x minus 6. Now, one of the things you're going to see whenever we do these radical equations is we want to isolate at least one of the radicals. There's only one of them in this equation. And when you isolate one of the radicals on one side of the equation, this one starts off like that. I have the square root of x isolated on the left-hand side. Then we square both sides of the equation. So let us square both sides of the equation. So I'll just rewrite it again. We'll do this one slowly. I'm going to square that, and that's going to be equal to 2x minus 6 squared. And
pause right there so you can write it down. So this, write it down right below example 5 on your notes on the backside. So the square root of x is a radical equation. It's equal to 2x minus 6. The way that we undo a square root is by squaring it, right? But if you square the left side, because that's the only thing on the left side, then you have to square the entire right side. That's how you keep your equation balanced, okay? So watch what happens next.
Squaring seems like a valid operation. If that is equal to that, then that squared should also be equal to that squared. So we just keep on going. So when you take the square root of x and you square it, that'll just be x. And we get x is equal to, this squared is going to be 2x squared, which is 4x squared. It's 2x squared, the whole thing. 4x squared, and then you multiply these two, which is negative 12x, and then it's going to be twice that, so minus 24x. And then negative 6 squared is plus 36. If you found going from this to this difficult, you might want to review multiplying polynomial expressions or multiplying binomials, or actually the special case.
You guys see what he did there? Yeah, he kind of did it in his head. He talked through it, but 2x minus 6 squared is 2x minus 6 times 2x minus 6, which we know would need to be FOILed out. So what is 2x times 2x? 4x squared. And then we have the middle two terms of negative 12x and negative 12x again. And then the last one times the last one, and negative times a negative is a positive. 6 times 6 is 36. We know when we FOIL, we can always combine the middle two. So what's negative 12 minus 12 more? Yeah, so that's how he gets to negative 24x plus 36. So that's all we did there. Okay, so now you can see this is basically a quadratic equation, which this is awesome review because quadratic equations are also on exam 3, upcoming next week. So how do we solve a quadratic equation? What's the first step? Before any of that. Before that. Before that. Get the x over. Get it set equal to 0. So we need to subtract this x over. So you'll see him do that in a second. Then we have two options to solve it. What's now, some of you are saying it. What's one option? GCF and factoring, right? A times C bottoms up. Or, the more recently, what we've did, it's hanging on the ceiling, the quadratic formula, okay? So he chooses the quadratic formula. It actually does factor, but the quadratic formula will be a good review here because that'll also be on the test.
So we square binomials. But the general view is this squared, which is that. And then you have minus 2 times the product of these two. The product of those two is minus 12x, or negative 12x. 2 times that is negative 24x. And then that squared. So this is what our equation has, I guess we could say, simplified to. And let's see what happens if we subtract x from both sides of this equation. So if you subtract x from both sides of this equation, the left-hand side becomes 0, and the right-hand side becomes 4x squared minus 25x plus 36. So this radical equation has simplified to just a standard quadratic equation. And just for simplicity, not having to worry how to factor it and group and all of that, let's just use the quadratic formula. So the quadratic formula tells us that our solutions to this, x can be negative b, negative 25. The negative of negative 25 is positive 25, plus or minus the square root of...
There we go. Let's see if we got our discriminants right.
Of 25 squared. 25 squared is 625 minus 4 times a, which is 4, times c, which is 36. All of that over 2 times 4. All of that over 8. So let's get our calculator out to figure out what this is over here. Let's get our calculator out. So let's say, so we have 625 minus, let's see, this is going to be 16 times 36. 16 times 36 is equal to 49. That's nice. It's a nice perfect square. We know what.
So that's your answer. 49 is the discriminant. If that's what the test asks you, that's what you would say. 49.
The square root of 49 is, it's 7. So let me go back to the problem. So this in here simplified to 49. So x is equal to 25 plus or minus the square root of 49, which is 7. All of that over 8. So our two solutions here, if we add 7, we get x is equal to 25 plus 7 is 32. 32 over 8, which is equal to 4. And then our other solution, let me do that in a different color. X is equal to 25 minus 7, which is 18 over 8. 8 goes into 18 two times, remainder 2. So this is equal to 2 and 2/8, or 2 1/4, or 2.25, just like that. Now, I'm going to show you an interesting phenomenon that occurs. And maybe you might want to pause it after I show you this conundrum, although I'm going to tell you why this conundrum pops up. Let's try out to see if our solutions actually work. So let's try x is equal to 4. So this, if x is equal to 4 works, we get the principal root of 4 should be equal to 2 times 4 minus 6. The principal root of 4 is positive 2. Positive 2 should be equal to 2 times 4, which is 8 minus 6, which it is. This is true.
So we plugged 4 right there back into the original problem. We plugged in 4 for the x's. The square root of 4 is 2. 2 times 4 is 8 minus 6 is 2, so it works.
So 4 works. Now let's try to do the same with 2.25. According to this, we should be able to take the square root, the principal root of 2.2. Let me make my radical a little bit bigger. The principal root of 2.25 should be equal to 2 times 2.25 minus 6. Now, you may or may not be able to do this in your head. You might know that the square root of 225 is 15, and then from that you might be able to figure out that the square root of 2.25 is 1.5. But let me just use a calculator to verify that for you. So 2.25, take the square root, it's 1.5. The principal root is 1.5. Another square root is negative 1.5, so it's 1.5. And then according to this should be equal to 2 times 2.25 is 4.5 minus 6. Now, is this true? This is telling us that 1.5 is equal to negative 1.5. This is not true. 2.5 did not work for this radical equation. We call this an extraneous solution. So 2.25 is extraneous solution. Now, here's the conundrum. Why did we get 2.25 as an answer? It looks like we did very valid things the whole way down, and we got a quadratic, and we got 2.25, and there's a hint here, right? When we substitute 2.25, we get 1.5 is equal to negative 1.5. So there's something here that something we did gave us this solution that doesn't quite apply over here. And I'll give you another hint. Let's try it at this step. If you look at this step, you're going to see that both solutions.
So he gets real mathy on you here for it. I'm not going to play the rest of it. I'm just going to play about the first 7 minutes there. But basically, what I want to remind you here, if I have x squared equals 4, how would I solve this problem? Square root both sides. What do we have to remember when we square root something? Plus or minus, and what's the square root of 4? 2. In other words, excuse me, there's two numbers. What's 2 squared? 4. What's negative 2 times itself? Also 4. There's two numbers that work. But notice, this problem isn't an x squared problem. It's a square root problem. So from the very beginning, they're saying the square root of x equals 2x minus 6. Are they saying plus or minus the square root of x? No. There's no minus sign in front of there. They just want the positive version. If they wanted the negative version, they'd put a negative in front. This is just an equation with one answer, okay? So basically, there's only one answer that works here. So we're only taking the positive primary root. So you can see when you plug this number back in, it actually doesn't work in the original problem because they only want the positive primary root, okay? So moral of the story, we're going to have to check our answers to make sure they work in the original problem. Yeah, if it was plus or minus, then it would work, but they don't want plus or minus. This is just an equation with a positive square root in the front. Okay, so now let's just work a few of these out, and we'll be good for today. So let's take a look at number 1, probably the easiest problem you will ever do for the rest of your math career. If I have the square root of x equals 2, how do I solve this problem? You square it, therefore x equals 4. If I plug it in, does it work? What's the square root of the positive square root of 4? 2. Yeah, so we can see that it works. Okay, number 2 on your notes. How do I undo the radical? Yeah, you square it. Watch what I do here. I'm going to put the whole side in parentheses and square it, because that's what Sal did. So I need to square the whole left side because the square root takes up the whole left side. But if you square the whole left side, what do you have to do? You have to square the whole right side. So I like to put parentheses around it to show that I'm squaring the whole side. So this becomes x minus 5 equals, positive 100, right? Because we take a negative 10, we multiply it times itself. Add 5 over, answer is 105. Now, if I plug this back in, what's 105 minus 5? What's the positive square root of 100? 10, not negative 10. So 105 actually does not work for this problem. We're going to call it extraneous or extraneous.
I don't like it.
So my algebra 2 kids always said. Extraneous. Stop it. Okay, example 3. Now I'm going to take, we haven't had this problem yet, but if you go back and look at the very top of your page, the first step is always going to be isolate the radical. Now we should be really good at that because we just did it a million times, but with absolute value. So the first step is always get the radical by itself. It's currently multiplied by negative 6, so we should divide both sides by negative 6. So we get the square root of x minus 7 is left on the right side. And now a negative divided by a negative is a positive. If you take both sides and square them, we would get 36 equals x minus 7. So the square always cancels out the square root. You're left with the radicand. We just learned that word. Add 7 over, and our answer is? I'm circling. Why aren't you writing? X equals 43. Kind of plug that one back in your brain. See if it works. Does this one work? Yeah, 43 minus 7 is 36. What's the square root of 36? Times negative 6 out front is, in fact, a negative 36. So that one works. Okay, now example 4 is almost identical to the one that he just did in the video. Okay, so take a second and go ahead and see how far you can get in example 4. Okay, if you're watching the video, there's the first step. If you can pause and keep working if you need to. There's step 1.5 and step 2. There is step 3. Subtract the 2x over, add the 1 over, so we get x squared minus 6x plus 5 equals 0. So here's our answers, 5 and 1. We need to go back to the original problem now. Plug in our answers up here and see if one of them or both of them do not work. So we can see here we simplify, or I plugged 5 back into the original problem. I plugged 1 back into the original problem. Now, which one of those obviously is not correct? The positive square root of 1. The positive square root of 1 is not negative 1. So this one would be extraneous. And then x equals 5 does work. The positive square root of 9 is 3. So with this one, if you square both sides, what happens?
It's just an easy problem.
It's just an easy problem. Both of the square roots cancel out. You get transported back to algebra 1 for a minute. Yay for algebra 1. Subtract 2x over. Add 3 to the right. Divide by 2. X equals 4. Spoiler alert, it does work. And for the last problem, I have a guest problem solver, Seth Grisham.
Hi, welcome to my ASMR channel.
Oh my gosh.
Alright, so first we're going to add the term, the square root of x minus 4, to both sides. So we're going to get the square root of x plus 8 equals 2 plus the square root of x minus 4. And so now we're going to square both sides in order to eliminate the radical on the left side. So it's going to be x. I don't like this. It's not erasing. Well, anyways, it's going to become x plus 8 is equal to, and then we're going to FOIL this. So it's going to be 2 plus the square root of x minus 4 times the same thing. So 2 plus the square root of x minus 4. Make sure that's under the radical.
And that's because we have this squared, so therefore we square the entire right side, so that's how we come out to that squared.
Thanks, Coach TJ. And so, if we FOIL this out, we get x plus 8 equals 4, because 2 times 2, plus 2 times the square root of x minus 4. And then we have another 2 times the square root of x minus 4. What's happening? I don't like this.
Keep your hand off of it.
My hand's not even close to it. And then the last term is x minus 4. really rough. Alright, so let's simplify. So x minus x is going to be nada. Then we're going to add this 4 right here and subtract that 4.
Those cancel. 4 minus 4.
Yeah.
So on the left side we have 8 equals. In the middle.
4 times this. What is happening? I'm writing, but it's not writing. X minus 4. And so this is going to be. That's not a 2.
Alright, at this point we would divide both sides by 4. So that's 2 equals the square root of x minus 4.
I hate this computer
We
screen.
square both sides. So we get 4 equals the square root and the square cancel out. Add 4 over, therefore x equals 8. Okay, so from here we would need to check for extraneous solutions. So if you plug in 8 for both of our x's, you can see we would have the square root of 8 plus 8 is 16, minus the square root of 8 minus 4 is 4. Those are both perfect squares. It gives us 4 minus 2, which does equal 2, like the right side of the equation.